Welcome to the HPC Best Practices webinar series. This series is brought to you by the IDEAS Productivity Project, which is part of the exascale computing project of the United States Department of Energy. I'm Mosny Marquez from the Los Berkeley National Laboratory, and I will be the host for today's webinar, Openscapes, Supporting Better Science for Future Us. The webinar will be presented by Julia Stewart Longis. I have seen the slides, the dry run. It's very nice. We're going to see very nice things here today. So Julia is the founding director of Openscapes. She's a marine ecologist and champion for making science more open, efficient, inclusive, and kind. She works at the intersection of actionable environmental science, data science, and open science. She's a Mozilla Fellow, National Science Foundation Better Scientific Software Fellow, and also Senior Fellow at the National Center for Ecological Analysis and Synthesis at the University of California, Santa Barbara. She earned her PhD from Stanford University in 2012, studying drivers and impacts of Humboldt squid in a changing climate. I had no idea of that kind of squid. It was so big, and I think you'll see Julia holding one of them. I'll stop my sharing here. Julia, you take over, please. And I think you are
great.
You are good. Okay, good.
Great. Thanks so much, Osni. Welcome, everybody. Thanks so much for having me. I'm very excited to be here. I will go ahead and share my slides. I think thumbs up if I think you can see these. Yep. Thank you. Thanks. So hi, everybody. I'm super excited to talk about Openscapes and supporting better science for future us. And yeah, thanks again for the invitation and having me at this webinar. At Openscapes, we believe open science can accelerate interoperable data-driven solutions and increase diversity, equity, inclusion, and belonging in research and beyond. And the purpose of today's talk is to share the open science mindset and some tooling with you and to welcome you to this broader movement. So we'll be seeing a lot of different themes and sort of re-examining them deeper and deeper through different stories and examples throughout the presentation. So first of all, to define better science for future us, we think about better science as being science that's more open and transparent, more reproducible, efficient, interoperable, and resilient. And also it's more diverse, equitable, inclusive, and kind. And we've defined future us as thinking about ourselves, as well as our teams and broader communities that we might not know yet. And thinking about these, thinking about us in that way on different timescales. So in the next hour, in the next week, in the next decades. And so this is a mindset that's really important, particularly in environmental science, where we're looking at how things are changing through time and predicting things in the future. But it's relevant for all kinds of science and beyond. But this type of mindset is also a real investment. It's an investment in time, in patience, in learning, and in resources. And this is especially true for data-intensive research. So to give a little bit more of a background of who I am, like Osni said, I'm a marine ecologist and I'm an Openscapes founder. And Openscapes, as we'll continue to see, the real focus is helping research teams transition to inclusive open science and data-intensive workflows. So you'll see that Openscapes mentors teams through these approaches so they can better tackle their questions by strengthening shared practices that are underpinned by tools that exist already. And the motivation for Openscapes is really from my team's own experience doing data-intensive marine science. And we really found out the hard way that our default approaches to how we were working with data and code and collaborating with software made our research not reproducible even by ourselves. And so I became an open science community member, particularly through the R community, which is a computer programming language. And that's really where I learned inclusive peer learning. I saw role modeled teaching and really community building across disciplines and career stages. So I want to address this photo here. This is me doing my PhD research back in 2009. And like Osni said, I'm holding a squid that is, quite nearly as big as I am. Its arms are kind of on the right side as I'm about to put it back into the water off the edge of a boat. You can see my colleague, John Field, holding on to me. And there's a satellite tag attached to the sort of foreground of the squid, to its fin. And that tag was going to travel with this squid as it swam throughout the Pacific Ocean. It's collecting data every second so that we can see where the squid is, what the temperature of the water is. You can actually see these animals breathing because of the way squids move. And we were going to be combining this with satellite data and remotely operated vehicle data to understand how this squid, which is the largest the largest invertebrate fishery in the world, but also one of the top 4 fisheries in the world by biomass. So that's all to say it's a very economically and ecologically critical species. We were going to be able to learn where this thing was swimming and going. It was really exciting. But I really soon felt demoralized by this, by my research, because when I got the data back, I couldn't analyze it with the tool sets I have. This is a feeling that is happening across science all the time in big ways and small ways, where we are facing a challenge that we can't solve with the skill sets we have. And it makes us feel like Luke Skywalker here when he's crashed his plane into the swamp of Dagobah. But the good thing is that there's other approaches that can help us think about these problems in a whole new way. If you think about how Yoda comes along and is able to solve Luke's problem in a way that Luke never imagined was possible. And Luke is going to be able to see that this whole new approach exists, and he's going to be able to learn it and take it forward to tackle challenges on a scale he can't even imagine. So for me, this was open science and coding and seeing mentors who are software developers and seeing this whole new way of working that I hadn't experienced in the marine science community yet. But the important thing here too is, Luke doesn't go on to save the empire by himself. It is a whole team effort, and there is such a diversity of skills and activities and ideas that are brought together, and that's really what made it possible, for the Star Wars story to succeed. But it's also what's going to make it possible in science and climate solutions to succeed. So through open science and mentors and coding, I really felt empowered to do this myself for my own research and to share these practices more broadly with other researchers. So over the last 10 years, I have built confidence as an open science contributor and leader through a lot of different activities and opportunities in the open science world, particularly through the R community, as you'll see kind of listed here, and as well as the Mozilla community. And this really culminates in our work with Openscapes, which is what we're going to continue talking about today. But as we go there, the open science is something I haven't quite defined yet. And we think about it as a movement. It's a movement that's happening globally across science. And it's not only about improving the way we share data and methods, but it's about improving the way we think and work and interact with each other. So it's really this beautiful interaction of technology that's enabling social infrastructure and influencing technology, and all of that towards kinder science and more collaborative and inclusive science. So open science is this movement within science, and it's happening across disciplines within science. It's also open healthcare is an example. Open government are other efforts in this broader movement. And the COVID-19 pandemic is a really interesting example of open science in action, as folks are sharing data in real time, code, reusing, map building and predicting things. So it's, this idea of the tools that we have and the culture we can create with that around collaboration is really exciting for open science. And there's also other movements going on in the world that we can align with and learn from. One in particular that we're really dedicated to is the climate movement, and the idea that to address our climate emergency, we must radically reshape society. We need every solution and every solver. This is what we see as possible through open science and collaborative ideas. So let's take a breather and talk about our goals for today. I would love to share, first talk about movement building and to share stories of open science for climate through a lot of the collaborators and leaders we have in the Openscapes community. And then I'll do a short skill building demo using software called Quarto that you'll see examples of throughout the stories. And then we'll end with how you can help your colleagues develop this mindset and join the movement as well. And I also just wanted to directly say why this is relevant to the exascale community. And really, it's we think about it because computing skills are really critical for science and society across so many different facets of what's possible today. And we really have been hampered by inequity about who is welcome to access these, what's possible with code and software. And this is something that we are working to change and want to invite you to help us change as well. And these are a few references listed here that show that the biggest unmet need in analyzing biological big data, whether this is genomic data or COVID data throughout the globe, is skills. The biggest unmet need for analyzing data are skills around coding. And this is a paper that it's referenced from 2017, and a follow-up paper by a lot of people from that same group in 2019 showed that the barriers to helping teach coding in bioinformatics courses is that the faculty and scientists that are coding themselves don't feel qualified to teach it to students. So even folks that are, a lot of us are self-taught, and there's a need to support us in teaching and also helping have that culture change so that we can all feel empowered to teach, even if we don't have formal training as computer scientists. And the last quote here shows that this is by Ruha Benjamin, that technology can exacerbate inequities if the corresponding social infrastructure is not in place. So just thinking about how to be deliberate about how we can welcome more folks into this wonderful world of coding and open science and possibilities. Okay, so let's go ahead with Openscapes. So with Openscapes, we think of open science as this beautiful landscape with many existing paths forward, full of code and data and communities. And what we do is we help researchers move from the lonely science, like these illustrated by these animals in the bottom left corner, and towards more collaborative open science as they navigate this landscape together safely with their teams. And in terms of safety here, we're thinking of like less trampling, less time being stuck in a roadblock. But the metaphors carry into open science and coding. And what we do with Openscapes is we meet folks at the trailhead and welcome them, help them sort of see what's possible in this landscape and get on those paths together. So we help them often, we introduce them to this landscape and also help them see that the folks around them can be part of their team and they don't have to do this alone. So we think of this as engaging, empowering, and amplifying folks around all of these practices. And our main activity is that we mentor professional research groups, and we're really focused on transforming the collaborative work practices, like the daily work practices that enable these climate solutions on all different scales. We've worked with over 700 people so far throughout government and academia and nonprofits. And we really, we've been learning a lot from these different movements that I was describing before, and have something that's kind of not your traditional training or workshop. It's cohort-based, it's remote sessions, and it's really about getting stuff done that you already have on your plate, but having to weave new ideas and practices and skills into your daily work so that you can be more efficient. And there's also a sustainability and scalability built in. We're really interested in developing teaching and learning cultures within different organizations, whether it's an academic lab group or an organization like NASA Earth Data. And the idea is that folks can support and help each other to change this culture. And so to that point, we really focus on how culture change requires, it's technical and it's human. It's about developing skills and mindsets in the same people so that you can transition, you can see that you're stuck and see that you could be a part of, you could learn a system like, having a tidier workbench, and that's something that you can actually do to share and teach and interoperate and work with others. They kind of develop these mindsets of seeing where you're stuck, learning and sharing as you go. So I wanted to share some specific stories through, and the way we were going to do it is to organize it through some of the values that have emerged as we've worked with all of these groups. So we'll walk through as many of these as we can before I switch off or I switch to the demo. But just to sort of as a disclaimer, there's so many amazing people we work with and stories to tell. So this is a very small subset, and each story will be able to kind of cross all of these categories in one way or another. So I'm going to have to really work to limit to the point. And it was also inspired in large part to some of the work that Abby Kuponok-Mays has done with Mozilla Open Leaders too. Okay, so the first one is the idea that open science is a process, and it's something that can inspire and empower folks. And I think that oftentimes open science can be thought of as products, like as data or code. And so this idea that it's also a process and it's got this human side of it is really a value that has surfaced for us. And the story with Ileana Fenwick helps illustrate this in a beautiful way. So Ileana is a PhD candidate at the University of North Carolina, and she's part of the core Openscapes team. And this is a slide from one of her presentations showing how it started on the left there, where she's kind of tangled with a lot of files that she's hand curating to have different versions of them, and how that led to a lot of lost time and data and frustration. And that through seeing what was possible in that open science landscape, she is now not only improving her own fisheries research, but she's also amplifying what she's learned to broader communities. So she, on the right here, she's telling her story and inspiring others through the Black and Marine Science Black and Marine Science Weeks. And she also gave a talk at our studio conference about her journey and how data science tools for equity, diversity, and diversity in STEM. So her story of seeing what's possible and then amplifying that as a process is phenomenal. And she now has her first grant to lead a event series for Black marine scientists in partnership with Black Women in Ecology, Evolution, and Marine Science, and Black and Marine Science that they're kicking off this month. So the beautiful story of seeing open science as an activity that you can participate in and then amplifying this beyond. The next value is this future us mindset. And I know I defined it a little bit at the very beginning, but it's really something that you don't do alone. You develop this mindset by thinking about this with colleagues and talking about this with colleagues. And so prioritizing that time to talk with colleagues and having some kind of structure or place to work together as you talk about things is really important. So Adian Rios is a marine ecologist at the NOAA Southeast Fisheries Science Center. And this is a slide from one of her talks where she's introducing the concept of their surf sessions at the Fisheries Science Center. And what these are hour-long meetings, virtual, that are welcome to everybody at their science center who are all dispersed. And the goal here is to create digital and physical spaces where their group members, despite having differing research questions and expertise and tasks on their to-do lists, it's a space where they feel comfortable discussing data challenges and seeking, offering, and accepting guidance from each other. And these surf sessions that Adi leads have just been really important for the culture at the Science Center and for people getting their work done. Adi, like many folks, onboarded to a new job during the pandemic and didn't really know how to meet people or learn what other people are doing or learn how she could contribute or how people might know things that could help her. And so having this on the calendar that everyone was invited to, and you knew that there would be kind of a Google Doc that had a little bit of an agenda, enough so there was a place to paste screenshots or paste links, or it was a culture where you can screen share with each other and show your error message. It was a place that really not only helped build this kind of future us mindset, but also is helping create this learning culture at the Southeast Fisheries Science Center. This next value is the power of yet. And this is really part of the growth mindset body of work that Carol Dweck has done. She's at Stanford University. This is the idea that we can all continue learning. And just because you haven't seen something before doesn't mean that you can't practice it, learn it, and contribute. So this is a really important mindset for folks that have not been exposed to coding before, in particular, and just kind of having this power of yet mindset when software is continuing to change. So this example is with the Alaska Fisheries Science Center Marine Mammal Lab. And this is a team that really embodies the power of yet. They this is a slide from one of their presentations where they show that, well, first of all, they practiced what we just saw with those deliberate meetings where you can screen share with each other, learn where each other are, and figure out how to interoperate more broadly with each other. So they started having those regular meetings within their team and kind of found the edges of their scopes of work and how they could help interoperate more easily between creating reports every year together. So where those handoffs were with data or with drafts of Word documents, that kind of thing, they decided, they kind of saw where those edges were and decided to learn GitHub together in order so that you could use it for version control and for communication. They also, in this example, in this screenshot here, started to use R more extensively on the left side here, they started to make maps and figures directly from R. And this was a huge step because in the past, there were, if there were 6 different people that were going to have a map at different parts of the reports, there would be 10 different ways of making that map. And now there is code that creates the map you need, and you can, modify it as however you need in R. And then the second part that is such an exciting example of this growth mindset is they also started using this brand new software called Quarto. And what this lets you do is have your code and text and outputs in the same text document called a Quarto document. And then that can be rendered into HTML or a .docx or a PDF. And so this let them, they saw this, and this was the power of yet, how can we build our workflows into this shared system that will make this more reproducible, make it easier for us to collaborate across responsibilities and skills, and tee us up for success more in the years to come. So this is just there's so much more to say about this group, and we'll explore this idea of Quarto a bit more in the demo later as well. Okay. Onboarding learners as contributors is another really important concept that's come up through our work. And Gavin Fay's group at the University of Massachusetts, Dartmouth, is a phenomenal example of this. The Fay Lab manual, which is on the right side of this, one of Gavin's slides here, is like a famous document. It is a openly created manual of how the lab works, like how to onboard people to the lab. And so it puts up front lab culture and philosophy, a code of conduct, and they consider onboarding not only like where your desk is and where, you know, here are your keys. It's about like, we have a folder here where we keep our data. These are where our presentations are. Please reuse them. We use R, and these are the packages we've made for our work. Like, here's how you can learn R so that you can be part of this, you know, infrastructure that we've created. And the reason, you know, I said this manual is famous. It's like, this is a radical idea in science, that you're creating this documentation that's open and out there, and learners, as they read it, are not only learning how to, you know, contribute to where they're going to put their data, they're also learning how to edit this manual using GitHub and Quarto. And they're able to contribute to it on day one. As they're reading this, they can fix a typo or add a new link, or, you know, embellish like a detail that they think is there. So, you know, it's this idea that like a learner can actually contribute to science on day one. And with that kind of mindset, it's just like, it's so exciting to think about where this will lead science. That, you know, traditionally you have to wait several years as a newcomer to a lab before you kind of have a voice in science, before you can publish peer review. This is a way you can contribute openly and bring your expertise on day one, and it's just so exciting. The other part of this slide shows, of Gavin's slide here, shows that they also use GitHub issues as a searchable repository for tips and tricks and new group knowledge. So this is another way that they're kind of onboarding new learners in a format that helps them contribute and helps them learn software as well as these concepts that are written through there. Slowing down to speed up is another big concept that comes through, and this is also about meeting people where they are. This is a wonderful example from the viability report team at the NOAA Fisheries Northwest Center, led by Eli Holmes, and how they focused a lot of their team building, their sort of surfside meetings or seaside chats, or, you know, whatever they called those meetings. They focused on kind of what their current workflows look like right now and who does what, so that they could then figure out how to streamline this. Just in the interest of time, I'm going to try to be a little less detailed about all these stories as we go forward. But I do want to share this next one to make the implicit explicit. And this is the idea that we don't assume what skills people have on a team. We're able to ask questions about in a safe space, like if people are comfortable using this type of software, or actually just taking the initiative to demo or screen share something that might not be, you can't assume that somebody might know. And this came through in a couple places in our NASA Openscapes work. This is a screenshot of a recent poster publication that they presented it at a big conference last month. This idea here is that this is a really wonderful project where we are supporting NASA Earth science teams to migrate their analytical workflows to the cloud as all of NASA Earth science, NASA Earth Data's archives migrate to the cloud as well. So this is a 3-year project that is a wonderful collaboration with NASA and their 12 data centers, where historically researchers had downloaded data individually from these 12 different places. And now that the data will be available in the cloud, there's going to be one unified system for researchers to access the data in one place. And our work with this group is to help those 12 data centers collaborate and upskill and learn about how to support researchers in the cloud. And the story here about making the implicit explicit is that, you know, we actually walked in and assumed that folks had experienced working in the cloud themselves already. And something we learned was that was some, you know, and we felt pretty uncomfortable. I had not worked in the cloud before. And without saying out loud, like, you know, have folks worked in the cloud before, we realized that this was a need, and we're able to collaborate with a group called 2I2C to establish a Jupyter hub. And we all learned how to work in Jupyter notebooks and create Python environments and all of that so that we could support this research. So, but I think, you know, being able to have those conversations and having kind of that space and place where you're building trust and being able to talk about what the needs actually are is a really important part of the work that we do. So this slide then goes on to show how this arc is on this left side, how our NASA Openscapes community of mentors then were able to help teach other folks at who are staff at their data centers, and from there then support end users who are researchers, and then also contribute back to this open science community more broadly in terms of resources and teaching. So this is kind of movement building in action that is really founded on this idea of making the implicit explicit and being able to identify and support where the needs are. So reusing and not reinventing is, what I'll say here is the California water boards have, you know, we've been talking about reusing code or data or technical setups. The California water boards reused the whole Openscapes Champions program infrastructure, and they have now they basically forked Openscapes and have now led Openscapes with their colleagues internally. And that's just like a wonderful example of reusing and not reinventing. I'm just gonna end on our last one so we can continue along to the demo. I'm sorry, I'm realizing how hard it is for me to shorten these stories. So the last value is kindness, and how this can emerge through inclusion, creativity, and art. And Don Wright, who's the chief scientist at Esri, encompasses this value so beautifully. Don was our first guest on our community call series, where we got to talk to her about how kindness has showed up in her science and really help amplify and discuss like the importance of the way we work together in the scientific community and creating the culture we want. So, you know, this was a quick little run through of these values, and something that underpins all of them are the idea of psychological safety and being able to ask questions, give feedback, have people to talk to. It's also another big piece of this is that people have had paid time to learn new skills, to teach each other, and to experiment with incorporating new skills and tools into their workflows. And that it's been a lot of little things that they've done on a daily basis. It's not just one big thing that you're kind of waiting to happen to you someday. It's like taking action on these many little things. So throughout all of this too, you know, open documentation has been key in a lot of these stories. And it's really important for science and storytelling and far beyond. So we share our approaches in several places, but these are our main places where we talk about our whole approach. And also we have a lesson series for the Champions program that has all of our curriculum, and we're constantly adding to both of these as we learned. And these were enabled through technology, like this mindset of being web first, of adding notes and developing things in the open, have been really enabled by technology, and specifically with Quarto. And Quarto is something that builds on R Markdown, which is something that's been around for the last 10 years. And I've had the great luck and privilege to be using for 10 years already. So this idea of what R Markdown is able to do helps me even like design the idea for Openscapes with this web first mindset, which is so exciting to see more and more in science. So what is Quarto? Quarto is a new open source scientific and technical publishing system. And the goal of it is to make the process of creating and collaborating dramatically better. Quarto lets you take your code in many different languages, and it will turn it into these different reporting formats. So like we saw with the Alaska Fisheries Science Center team with their map of Alaska. And I keynoted the global launch of Quarto earlier, well, I guess last year. And the reason that I was part of this keynote was that NASA Openscapes was the first Quarto external user of this software. And that's a story in itself, and told through our keynote here. But it's been a wonderful collaboration to actually have me as somebody with R in my background coming to the NASA Earth data world, that Python is their main language, and having us be able to interoperate and build documentation and teaching resources using Quarto together, and helping contribute even to some of the design of Quarto. So what I'm going to do with this live demo is to show you in the RStudio software, how to develop a small website using the Quarto text file and R code. Then I'm going to show you in Jupyter Hub how we can add a Jupyter notebook.ipynb file and some Python code. And we're able to sync between this workflow using, I can't copy that. I'm going to copy it from over here. Using GitHub. Okay. Oh, and these are the things that I'm going to show, but we'll just go back there. Okay. So let me show you this demo. So I'm going to come here to RStudio and show you this. This is the RStudio IDE. This is the integrative developer environment where I have my kind of editor area here where I can have files open. This is my console where I have the live R process. And then I have a lot of nice tools at my disposal on this side. Right now I've got this file pane open where these are all the files in this project I'm going to show you. That's our website. And then I have a couple panes up here where I'll actually be able to render my website. So what I want to show you here is that this file, this YAML file, kind of gives the architecture of our website. We're going to have a welcome page called this index.qmd file, and then this hello page. And let's just look at this hello page first. And what this is a text file that combines some metadata at the top, but really it's markdown prose that I can write in. So if I was writing my fisheries report, I could write my introduction here. And then there's actually code here this is example code in R. I can run this code as I go, and it sends my code down to my console, so I can load this Palmer Penguins library that is a data set of, in R, we often package data as a code package so that you're able to share data nicely for teaching resources and beyond and analysis. So This example file has this mix of markdown text and then a few places where we can run code and actually look at the raw data that's in this penguins data set, for example. This has been kind of the primary way to interface with these Quarto files so far, but the visual editor is also a new feature that RStudio and now Posit has released in the last year. And what this does is this lets you see that same file, but more in a notebook view. So you can actually see a little bit more about what the code looks like as you run it. You see the things hyperlinked rather than markdown. You can have your images show up and have things kind of here together a little bit more. So what I want to show you though is how to turn this this flat file and this architecture we just looked at into a website. And so Quarto knows, the whole RStudio IDE knows that this is a website. So when I press this render website button, I get a little preview here of what our website looks like. So this is this welcome page, and then we can actually look at our Hello Quarto page. And this is this rendered view of what our website looks like. And actually, when we looked at the code with the raw data, we can also anyway, we were looking at it in several different ways. This is the code that will make a figure, and actually the code has been executed, and we've got the figure demonstrated here in our little website, which is awesome. One thing, that's all I'm going to say about Quarto, and before we move on, except for one amazing feature, which is around citations. One of the things that the visual editor now supports beautifully is citations. So when I press this @ symbol, I'm able to search my whole Zotero library, or even paste a DOI. So that's what I just copied. This is the original paper for this Palmer penguins. And so I'm able to add that right easily like that through this little interface. And then when I, again, build my website, and then let's have a look here. You'll see that this, I guess I need to actually render the page itself, which is nice, so that if you have code you actually don't want to run, building your website won't do it automatically. So that's good. But you'll see that this reference shows up nicely here, as well as by default giving you a reference down here. And this has been so huge for particularly the NOAA groups that we've been working with, who are creating annual reports, and citations is a huge time thing for everyone. Okay, I'm just going to show you this briefly in our Jupyter Hub as well. This is our Jupyter Hub, where again, it's hosted by 2i2c, and we have a Python environment that has been set up by Luis Lopez. All of our files are that I just had in RStudio are here. We can pretend that I just synced them using GitHub. And something that I've done here is I've added an IPyNB page to our architecture here. And we can look at what that looks like. This is a Jupyter notebook. So it's a similar feel to what we just saw with the Quarto file. And here, when we run this code, there's a Python library also called Palmer penguins that has been built by McNackey username. Anyway, so we can now see this same kind of orientation in a Jupyter notebook. And when we now come here, there's not a button yet to press build the website, but we can say Quarto preview from the terminal. And what this will do is give us a URL that we can view. I like to kind of put this in a window just to the side. Oop, let me just bring this over here. So this is, again, our website. Now there's this Hello Quarto in Python page, and you'll see that it has the same look and feel as our page that we looked at before. And one other thing I'll say is that our Jupyter Hub here does not have R installed, and my R instance did not have Python installed, but we're able to interoperate to create this website together. There's so much more I could demo and share, but we're gonna just leave you there with that taste and go back and wrap things up because I know we're getting towards time. So this is what I just demonstrated, is that you can collaborate across coding languages and contribute from your current tools, which has been really phenomenal. So let's return to movement building and kind of what's possible because all of this is, it's great, but what is really possible? And really what it means is there's more time for science and solutions. This is about time saved, but it's also about better products, less lost day to day, less things lost when people leave the group, less worry about that bust factor, if what would happen if your computer got destroyed. It's also about improved morale. It's about helping people get unstuck, building real relationships with colleagues. And it's about climate and social change. It's about really connecting our biggest challenges with our daily activities and work, and helping us be motivated and connected in that way. So to join, we invite you to join and amplify the open movement. And there's many ways to do this. We have these open educational resources that link to a lot of other communities and activities and resources. So this can be a good place to start. Also just, it's about this mindset too, this idea that open science is this daily practice and that you can reuse and not reinvent. This idea of learning together first and like having that kind of seaside chat, surfside chat thing where you can build that higher morale and skills. So I won't walk through all of these here, but I want to just end on the idea of this last point of, really listening to colleagues, learning from each other, borrowing what works, wherever you see it, and then also helping that kind of reimagine the places you're stuck on all different scales. And so to just close on this idea of reimagining and coming back to cephalopods and marine animals, since that's where I've started. This is a story that I got really inspired about over a break about the Lady and the Octopus, which is written by Dana Stoff. This is the story of the Argonaut octopus, which is displayed here. They wanted to live life a little differently by being an octopus that lived in the open ocean. And so what they did was build, through evolution, have built a container to enable that vision. So they actually build their own shell and wrap their arms around their head that you can see kind of cascading around their eye there. And they swim around the open ocean. And it's like this awesome octopus that is like doing things differently. And this book tells a story of Jean Villepreux-Power, who is a scientist in France in the 1800s who built aquariums to actually study these and like revolutionized marine science. So it's like really cool to see these different places that like spark your interest and help bring that to your own work to help you reimagine too. So I will end there and just say thank you. This is possible because of so many wonderful people that we work with, and we hope to see you again soon. Thanks.
Thank you, Julia. There are a couple of questions here. The first one is from Alfred. I would like to invite people to unmute and ask directly if they would like, otherwise I can. Alfred, would you like to do that?
Yes, I lost my connection for a few minutes. So actually, I lost my question in chat as well. So I try my best to recall my question. So basically, I think the question has to do with my observation that Openscapes seems to be more like a social attitude of how science ought to be done and to be more fair, more democratic. The idea of democracy is that everyone has a voice, But that's a good thing. But that also opened the possibility that bad data and bad ideas also have a voice in a completely democratic society. So, so when science is really that open, how do you win out bad data and bad ideas when everybody has a right to make an opinion, and that include bad data and bad ideas as well?
Mm-hmm. That's a great question. And one of the big things that we think about is how open science is really a spectrum in terms of how you participate and how open it really is. With a lot of the teams that we work with, we focus actually on being open within your team first. So within a lab group, within a division, in a government branch, and how can you be more open with the ways that you're working day to day so that your work is better for everyone. So it's not only about being public. A lot of the groups we work with are working openly together with their teams, but not openly publicly. And I think that that's really a big part of building kind of the trust and then sort of extending that beyond.
So there is a question here in the Google Doc. What is the difference between using Jupyter Notebook versus Quarto? I'm confused how to use which or when.
It's a good question. They are pretty interoperable and growing more so. So like I showed, you can combine them in the same project. So like if your collaborator is using Jupyter, a Jupyter Notebook, that doesn't, you don't have to use a Jupyter Notebook if you have a different system already. I think you can also, there's a actual function that you can run from the terminal to translate a Quarto document into a Jupyter Notebook and back and forth, which has been helpful. That's been one strategy that we've used as we use GitHub with Jupyter Notebooks, because the Quarto files can be a smaller file that works more nicely with version control. I think the idea but stepping back, the bigger mindset is that you can use whichever one works for your own workflow right now. You don't have to learn a whole new thing in order to use Quarto. So like if you're already using Jupyter Notebooks, that's great. You can continue doing that and still leverage Quarto. In the R world, we don't use Jupyter Notebooks as much. We use these Quarto documents, and so that's kind of our starting point. But we don't have to learn how to use Jupyter Notebooks in order to collaborate with Jupyter Notebooks. And that's not to say we won't. Like I've learned so much about Jupyter Notebooks, but it didn't have to be my very first hurdle in order to collaborate. And I think that that's really this power of yet.
Any further questions? Someone wrote here that the participant wrote that she or he loved your instructions and is asking how to incorporate them into the presentation, but someone is already answering that question.
Wonderful. Yeah, my colleague Stephanie Butland. Thank you so much, Stephanie.
Yes, thank you.
Yeah, so Allison Horst is an amazing artist and data scientist and teacher, and we've been collaborating for years on this artwork. It's all available for reuse and remixing, and Steph has links there in the doc. So thank you, Stephanie.
Any further questions from the audience? Please unmute and ask directly to Julia if you'd like. We'll do so.
I just wanted to say thank you so much for this. It was really great.
Thank you. Hope to see you again in other venues.
Questions? Thank you all for joining us today. We will skip, usually we have the webinars on a monthly basis, but we will skip February because there are lots of conflicts. The next webinar will be March the 15th, and people will be receiving more information about it. Thank you again, Julia.
Thank you all. Thanks so much, Osni, et al. Thank you. Have a good day.
Bye.